Good night, everyone. My name is Xu Bo. I'm a PhD from Nanyang Technological University in Singapore. My presentation is about the evaluation of the feasibility of reusing freshwater sludge in geotechnical engineering. The main content of my presentation include the production of freshwater sludge, we call it FS, characterization of FS, and potential application of FS in geotechnical engineering. Firstly, let's look at the generation of FS. FS is a byproduct generated from the water treatment process. This figure shows the typical water treatment process. In the first steps, the raw water from reservoirs is chemically treated, filtered, and disinfected at a waterworks. Then, the coagulants are added to binding smaller particles to form larger and heavier clumps. The third step is called the sedimentation. Large clump particles set to the bottom of the sedimentation tank and are moved. The removed particles were filtered or pressed to cakes, so we call it freshwater sludge, FS. Here's the image of freshwater sludge. There are about 10,000 tons of freshwater sludge produced worldwide per day. They are largely dumped in landfill. If we can reuse freshwater sludge in civil or geotechnical engineering, it will achieve both economic and environmental benefits. In the second part, I will show you the characterization of FS. I have done a literature review for the chemical composition of FS. This table shows the main oxide detected by XIF from different studies in different countries. We can find that the quantities of the oxide are quite different, but the main types of oxide are similar. They are aluminum trioxide and sulfur trioxide. These two are from the coagulant used in the water treatment process, such as aluminum sulfate. The third one is the silicon oxide. It is from the water sources. We also detected the loss on ignition. It varies from the 66% to 42%. This is due to the different water sources in different countries. Let's move on to the mineral phase of FS. From different studies, different kinds of minerals were detected, but the main minerals are aluminum sulfate compound, kaolinite, and quartz. This figure shows the typical oxide pattern of FS. For these minerals, we can find that the main elements of these minerals are aluminum, silicon, and sulfate. This figure shows the typical TG analysis of freshwater sludge. At 300 degrees, we can detect the decomposition of aluminum hydroxide. This table shows other chemical and physical properties of freshwater sludge, and we can see the quantities of the organic matter content, pH, water content are quite different. For the water content, some studies reported more than 600%. It is because that in some water treatment process, the freshwater sludge is not filtered or pressed to cakes, so they are in the slurry form, so they have a high water content. This also affected the liquid limit and plastic limit. For the mechanical property of freshwater sludge, these studies measure the shear strength and coefficient of compressibility, coefficient of condensation. So this result, the compacted FS has a high shear strength and a low compressibility. Another studies use FS as an additive in soil improvement and found that the consolidation sediment decreased by up to 6%, which means that FS have a potential application in soil improvement. Due to the content of FS, some studies try to use the oleum sludge for the stabilization of dispersive clay with high content of sodium ions. Because of trivalent cations of oleum in FS may replace the sodium ions, changing the soil structure from dispersive to condenser state. So it means that FS may be used as an binder for the stabilization of the dispersive clay. Due to the high content volume of the FS, some studies also use it for the expansive soils because it can improve the compaction parameters, CBR, UCS, and sweating properties. So another potential application is using the FS as the stabilizer for expansive soils. Here is another interesting study. It is reported that FS can be used as an efficient adsorbent for heavy metals. FS can be used to remove different heavy metals, for example, the Pb, Cd, and Ni. So, which is that we can also use FS as a binder for the treatment for heavy metal contaminated soils. Some other studies also reported different applications of freshwater sludge in geotechnical engineering. For example, FS can be mixed with soils, limes, or rock powder for the cover of vast landfills, or used in the construction of embankment on subsoils, or used to determine the level of dewatering necessary for landfills, or used as a liner for the landfills without pollution problems. It also reported FS can be mixed with soils. It can increase the maximum dry unit weight and decrease the optimum water content. The compressive index CC of the mixture is higher than that of the soil, so it can improve the CC value. I'll give you a summary. The quantity of the chemical and mineral compositions of FS from different literatures vary largely, but the main oxides and minerals are similar, including oxide such as aluminum trioxide, sulfur trioxide, and silicon dioxide, as well as the minerals of aluminum hydroxide, aluminum sulfate, and kaolinite. The chemical and mineral composition and property of freshwater sludge implies that FS may have the potential cementitious property. The mechanical property of FS implies that the compacted FS have a high shear strength and a low compressibility and can be used in geotechnical engineering under proper design conditions. The possible use in geotechnical engineering is reusing FS as a binding material for soft clay stabilization, dispersive clay stabilization, expansive soil stabilization, and treatment of heavy metal contaminated soils. In Singapore, there are about 50,500 tons of freshwater sludge produced from the waterworks yearly, which is currently filter pressed to the sludge cakes and dumped in landfill. Our research aims to recycling freshwater sludge in civil or geotechnical engineering. This research is supported by the National Research Foundation Singapore, National Environment Agency Singapore, and Singapore Water Agency. Thank you.